All right, thank you, everyone. Thank you for joining Router and Roy's session on how fact-based modeling drives data architecture and data development. Router and Roy work for Deltique. Router is responsible for knowledge development and coaching of consultants. He leads and executes data management and data governance projects at leading companies and nonprofit organizations. Roy has extensive experience in information and requirements analysis, solution design, and IT architecture. He has a lot of experience in implementing and managing large-scale data management, BI, big data, and analytics environments. Welcome, Router and Roy. I'll turn it over to you, Router. Thanks.
Yes, thanks, Steve, and thanks for your kind introduction. And to the audience, thank you very much for joining our presentation today. So I am Wouter, and I will be presenting with my colleague Roy. And as Steve mentioned, we both work for Deltique. We are a small data management consultancy company in the Netherlands, and we focus on helping organizations design, implement, and run data management capabilities. And today we will be sharing our experience about how we have set up a data modeling capability at one of our clients. And we'll take you through the context, the key problems, the solution we implemented, the challenges we faced along that road, and some of the lessons learned. And as you will see and hear in the next 40 minutes or so, the focus in our presentation is very much on the how, on the practical challenges. So how did we do this in a real operational environment? And we hope this will provide you with some practical guidance in addressing our or your own data modeling challenges. So we prefer to do our presentation first and then answer some questions at the end. So please, if you have any questions, put them in the chat and we'll cover them at the end of the presentation. So without further ado, let's start. Just switching to the next slide. Yes. So just to give you a little bit of context about the technical and data environment in which we develop this, what we call the data modeling pipeline. Just a quick overview. The client's environment is a Microsoft Azure environment where we've built an analytical data platform to support analytical processes in their primary processes. It's based on Azure. A very basic architecture with an area we call the persistent staging area, which we use for the historical storage of source data. Then we have an environment which we call the integration area, which is, well, so you can see it as a kind of data warehouse environment in which we address some logical concerns like referential integrity and quality and naming. And then we have an environment which we call the data mart area, which we use for preparing data for particular use cases and applications, where we use Power BI, Databricks, and so on. We have a couple of sources which we source and run through the data platform. So nothing very fancy or high tech, rather basic data architecture. And what's important for our story today is that we focus on what we call in this environment the integration area, which is a set of databases in which we want to manage some concerns which are depicted here on the right hand side. So we have chosen that we want to do basic third normal form data structure. That's a kind of decision we made within the client. Obviously, a lot can be said about that particular choice, but I want to refrain from that right now because the focus is on how we work towards those data models and implemented the data modeling pipeline. So when we set up this environment and this data architecture, there was a rather strong consensus that data modeling was necessary and would add value as a means to address particularly the concerns in the integration area, and basically because of experience of some of the team members with fact-based modeling, fully communication-oriented information modeling, and support by CaseTalk, we made a decision to use that as a basis. I will come back later in the presentation on the particular merits of fact-based modeling. And we also had a strong preference of trying to achieve model-driven development. So we wanted to generate, in the end, physical models from CaseTalk. So that is why we also started using ER Studio, because CaseTalk was able to generate models that could be further used within the ER Studio environment. And basically, because of the pricing of ER Studio, we made a choice to use that particular tool. So just to set the stage a little bit about the context in which we developed this data modeling pipeline. So excuse me. Basically, there were two challenges, and the first challenge was that although there was a common understanding that we wanted to do and implement data modeling, there was no standardized way of working. So not with regard to modeling itself, so in terms of model strategy or model standards, but also we experienced insufficient understanding that data modeling itself is a profession rather than simply drawing lines and squares in PowerPoint. And also, although we acknowledged that data modeling was necessary, there was basically no idea about how that would need to align with the system development lifecycle we used for developing analytical applications, and how a modeling way of working should align to data engineering efforts. So no standardized way of working, and also what we experienced basically from the very first moment is that although we made a choice for a particular tool set, it's just that we had the tools, but there was no idea or setup how we should basically integrate those tools and use them in a development environment, and how that could sufficiently support our modeling activities. As was shown in the previous slide, we use the Microsoft Azure stack. Well, Microsoft Azure doesn't support data modeling in any way whatsoever. So although this particular client has a Microsoft first approach, it was necessary to switch to other tools, but then we needed to think ourselves how we're going to set up those tools and going to integrate them with the Azure environment. So what we will be sharing with you in the next 40 minutes is we developed an end-to-end way of working that aligns with the system development practices at the client, how they wanted to do data engineering, and also some agile practices. And we will show how that is supported by CaseTalk and ER Studio, and how we have amplified that support with some custom macros and automation we put in place ourselves. And this will showcase, hopefully for you, that this allows the data modeler to address concerns at the appropriate level, at both the conceptual, logical, and statistical level, while also maintaining consistency between all the different kinds of models. And fourth, it also allowed us to govern the data architecture. So, Roy, can you elaborate on the overall approach, please?
Sure. Hi. Yes, we'll be presenting or demoing a, let's so to say, 6-step process. The first step that we will be demoing is the step in which we generate a ER Studio artifact file. We model the case, in CaseTalk, we model the conceptual data model. We generate an artifact file, a Visual Basic script, and we use this as the basis for our first macro. The first macro loads the generic Visual Basic artifact and adds some metadata, does some changes. And in the third step, we generate an overrides template file. The template file is initially empty, but it's pre-filled with all the domains, entities, and attributes. Can you please return to the Yes, thanks.
Yes, thank you.
And in the fourth step, we fill the overrides file with all the overrides we want to commit on the initial logical model that was generated from the CaseTalk. And in the fifth step, we generate the physical data model, and in the sixth step, we generate the DDL script. This all is being backed up by a bunch of macros that we've developed in ER Studio. I'll be showing you the working of the macros later on in the demo. But first, I'll be taking you with a dry run to the different steps. The first step that we do is that we generate a relational model on this conceptual information model in CaseTalk. And the second step that we do is we generate an artifact file. As I mentioned earlier, the artifact file is a Visual Basic script, kind of old school, but still works fine. And the Visual Basic script is being fed into ER Studio. The second step that we do is that we load the initial Visual Basic script with a macro inside a new logical model inside ER Studio. We pre-fill some extra metadata, as you can see on the right. This metadata is being used to generate standard file names, but also enhance the findability of the models and standardize models in overall. It's also possible, can you please go back to the first? It's also possible to import the CaseTalk file directly into ER Studio, as I mentioned before. However, we didn't choose to do that because we want to make some additional changes to the logical model. We want to add some relevant metadata, remove some redundantly generated views. We fix some syntax issues, and we save the file according to a naming standard, thus standardizing the format. Yeah. The third step is that we generate the overrides file, as you can see right here. It's in the Excel file you see over there. And the overrides file is a way to ensure that we can rerun changes or recommit changes to the model. Once it's being regenerated out of CaseTalk, we can override the overrides inside a new version of the model.
Yeah, just to elaborate on that a little bit, what you see here, the logical role name, those are the role names that are generated from the CaseTalk model. And as you can see, this is a consequence of the fact-based modeling method. Those role names can be rather long and particularly in some particular occasions rather cumbersome. So if we would just generate through and through to the logical model and the physical model, we would get these kinds of physical column names in our physical model. And well, that's not something that we want because of readability and also because of some strange characters. So that was a strong driver that we wanted to basically override or basically add physical column names to the logical names. Yeah.
And then, thanks, Wouter. Indeed, once again, the overrides file makes sure that we can rerun the changes every time we generate a new logical model from the conceptual model. The fourth step that we take is that we override the fields accordingly, according to the overrides file into the logical model. We can rerun it every time again. And in the fifth step, we generate the physical model based on the logical model. We generate a SQL Server specific physical model. This is all being done, by the way, by scripting. It's a matter of minutes. Also, we do some technical adjustments in this phase. We add some define clustered primary keys. We fix some primary key and foreign key naming conventions. We add additional plumbing fields, such as the load date timestamp fields and stuff like this. We delete some unnecessary constraints. All in all, it's being set up in a phased step, and in each phase we address the concerns that that are relevant in this phase. And in the sixth step, we generate the DDL code. We address the data management profession with a few questions, and based on those questions, we generate the DDL. which is then able to be exported to the data engineers.
Yeah, and we will elaborate a little bit on that later, how we do the handover between the DDL we generate and the data engineer who actually develops and modifies the database. All right. Guy, can you switch to Roy's screen sharing, please?
Oops, excuse me. Okay, so for those who are not familiar with CaseTalk, this is CaseTalk. This is the environment in which you model conceptual data models. As you can see here, I have generated, I've set up a demo environment. I will not be elaborating on this model in itself, but it's just being used to give you an idea of how the process works. After we're done as in the modeling phase, we generate a relational model. That's a step that we do inside CaseTalk. So we run the transform button, we run the transform feature function. The model gets validated via algorithms, and a relational model is being set up. As you can see here, the red, I don't know the English word, but the red object here. And based on this relational model, we generate the ER Studio file. The ER Studio file is being generated by this function, as you've seen earlier. It's possible to generate a new one. I'll be running this one. By the way, you see all kind of options here. We've chosen not to use these options because you need to set them every time again you run an export. We've chosen to override them in the overrides file. It generates a Visual Basic script. I'll just use this one. So I'll override this one. Yes. And as you can see in CaseTalk, you see a preview of this file, and it's good old Visual Basic. It generates the domains, the entities, the attributes, and stuff like this, the constraints, the foreign keys. So this file is being used as the basis for our ER Studio macros. So I'll be closing this. This again, this too. This is ER Studio version 19.1. I've opened the new model. As you can see, it's empty. And the first step that we do is we create a new macro. It's pretty illogical, but it opens the macro editor window, as you can see here. I've already opened the macros that will help us in the steps to DDL code eventually, and to generate the logical model. And I will create the first, I will run the first macro. This is the first one. The first one is to create a logical model from the conceptual data model. So I'll just run. This is the run button. And the first step is that it asks for the original CaseTalk file. So it's this file. And it processes very quickly. There were some tweaks in the interface. If you disable the updating of the backend interface, the scripting runs much, much faster. So this is, we found this during the development phase. Anyway, the first step that you see here is that it generates a panel in which you can enter some information. This is the project or application name, responsible data modeler, the organization, and some description. So we'll change this just to show later on that it's used. All this metadata is being saved within the logical model. Let me save integration area. It asks if we want to save the model. I'll say yes. I don't want to change the location, and it uses the same location as where the artifact file is being stored. So it will be under DMZ demo. Now, this is not much fancy. The most fancy thing in this script is probably this logo. But anyway, you see here on the back side, on the background of this script, you'll see the data model. What this first script has done, it has colored some of the artifacts. So for instance, the foreign keys were colored. Not much fancy done over here. The model metadata is being saved inside. I think it's been a while, but the main model has metadata in which you can add and you can edit. So this is the first step. What it's done, it has read the artifact file into the logical model, and it's being saved on the basis of a standard name. So you see a name here that's being standardized for all the models that are being created. The second step is that we generate a overrides file. So I'll run this second step. It asks for us where to write. I'll say cancel, and it picks the same location as where the original model is. And the file is being generated into an Excel file, as you can see here. I'll open the Excel file. And this is the overrides basic file. It's empty. You see that it takes over the metadata. And here you see the standard entities that are being generated by CaseTalk. And let's say, for instance, I would like to change the name of a table. Let's say project member with an underscore. I would like to say it is member. So every time CaseTalk generates a logical model artifact file, with this overrides file, I can override this name into this name. I've got some options here to write down the namespace, global. I get some owner schemes, source schemes. Anyway, for the demo's sake, it's not really important what these mean, but they have all, obviously, they have some meaning in the entire process of development. In the attributes, you can see as well. In especially these kinds of names with slashes in them or other different signs, it is necessary to set a different name. So for instance, I will change this name. These are some fields. I'll just change this so you can see that the changes are being picked up later on. I'll change the description, domain. I will change this to varchar 255. I'll save this. I'll shut down the Excel file. So the overrides file is being saved. And in this next step, I will use the overrides file to override all the stuff that I've entered in the Excel file. As you can see in the logging output, stuff is being added and changed. I'd like to save it. So if everything goes right, we should have some adjustments. What stuff did I fix, change? You can see here, the description should be a domain of varchar 255. I'll be going to, I'll be going to the domain interface. Luckily it works. I've changed the description domain data type to varchar 255 as mentioned, and I've did some other changes to the model. I think you all believe that this will be fixed with the scripting. Maybe just to be sure to show you. And the default column no role name for this foreign key relationship, which is the manager of the department, is named boss. So the changes are being picked up and work fine. And once a new model is being generated from outside CaseTalk, we can override these files again, and the changes are being done on this model. The fourth step is that we create a physical model. I'll just run it in the same way. I want to save it, yes. I've done some changes. I've standardized the names of the indexes. I've clustered the primary keys and added some status fields, engineering fields, those fields like this. I've added them to the different tables. As you can see here, stuff is being added. You can see the boss still here. Department name is being called dep name in the physical version. Yeah, that's about what I wanted to say about this. Oh yeah, you can see also that the schema name for a project member was changed to integration area, because I just said that it should be like this in the overrides file. And based on this physical model, I can create a physical DDL code. Would you like to implement foreign keys? No. Would you like to generate the primary keys? Yes. Would you like to save it? Yes. Okay. So this is done. And as you can see, I've generated a CaseTalk-DDL SQL file with all the necessary changes in it. Department name, boss, and I think the description should somewhere be 255. Where's the description? Project 255. So those changes are being set up accordingly. I have two other scripts, but I won't be mentioning them in this file. I'll just be mentioning what they do. The mapping generate script is a source to target mapping script that generates an Excel file which pre-fills all the fields. And the standardized reverse engineered model is that when we reverse engineer a logical model from a physical model, we standardize layout, we standardize metadata so that it can be used later on in the normal pipeline. So this concludes the demo. And I'll be switching over to Wouter again.
Yes, thank you, Roy. Just to add on, I think it was step 4 where we generate a physical model. Obviously, in RStudio, it's generating a physical model is a standard function, so you can just push a button and generate the physical model from the logical model. But as Roy has shown, is that we don't use that functionality. Instead, we made this custom script, which in the end generates the physical model, but also does a lot of other stuff. So and obviously that extra stuff like those plumbing fields and some cleanup is not something which is in the standard generate function of RStudio itself. So thanks, Roy. And so hopefully this has given you a little bit an overview of how this entire modeling pipeline works. In practical terms, we want to dive a little bit into the benefits and the results which it has given us, but also in some practical challenges and some drawbacks we experienced. I also got a question, I will answer that in a moment, about whether or not you can do the conceptual modeling in RStudio as well. So just to just to highlight some of the results and the benefits we've experienced. So, and this is under the condition that the entire pipeline Roy just demonstrated runs smoothly, because along the way we experienced some challenges. I will elaborate on that in a moment. So, under the condition that this pipeline end-to-end runs smoothly, we experienced that about 75% of the modeler's effort can be devoted to the conceptual modeling. So, and we think this is a very important benefit, because obviously technical concerns and logical concerns are important, but concerns like semantics, data quality, integrity, in our opinion, should be solved and addressed at the earliest convenience. And it can be done in the conceptual modeling stage. What we've experienced is that we really can put all our efforts in the conceptual modeling stage and talk with subject matter experts and business people to get their requirements clear and the data model clear, instead of having to spend our time on all kinds of technical concerns. So our estimate is that about 75% of the modeler's effort is devoted to the conceptual modeling. About 10% is spent in improving naming, setting data types, and adding some constraints, which is mostly done using the override file Roy just demonstrated. And that leaves about 50% of the time that we spend in running the entire pipeline testing whether all the models are correct, and also doing comparisons with previous versions of the model, and decide upon which changes to promote to the next version. And we'll come to that, how we do that, compare and merge, a little bit later on. So all in all, the lead time for delivering the DDL, I should say, once the conceptual model is done and validated, is about 10 to 15 minutes. So once you have done all the physical modeling, all the conceptual modeling here, and the model validates, and once you press the button to generate the Visual Basic script with the Ear Studio code, which can be run into Ear Studio, the entire lead time is somewhere between 10 and 15 minutes before you're able to deploy the DDL code. And obviously that depends on the kind of additional overrides and constraints you want to apply along the way. And we think this is well, as I said, a rather important benefit and achievement, because not only does it allow us to spend most of our time on the conceptual modeling, but it also allows us to maintain consistency between all the different kinds of models, something which we also tend to call vertical data architecture. And it also allows us, using this pipeline, to address the concerns at the appropriate level. So to elaborate on that a little bit, so we often talk about separations of concerns, which also apply within data modeling. We have conceptual concerns like semantics, mostly logical concerns, and physical concerns. It's for a reason that we also have three kinds of data models. And using this pipeline, we experience this really allows us to address those concerns at the appropriate level. What we see often in practice, and I assume some of you in the audience will experience this as well, is that there's a tendency to immediately go into the physical model and model a structure that can be implemented immediately, which can be done, of course, but it also requires you to address all the concerns at the logical and the conceptual level at the same time, which I think is well, it can be rather hard. So we use fully communication-oriented information modeling using CaseTalk, and running this way allows us to put full effort on that. And one of the benefits and the merits of XCOEM is that it's communication-oriented, so the requirements are expressed in natural languages, in sentences, and that really allows us to easily communicate and discuss with subject matter experts what they want from their model. Also, the method is 100% conceptual. So within fact-based modeling, you don't need to concern about what is becoming a primary key or a foreign key, what should become an entity or an attribute, and also the data types. So it allows you to really fully concentrate on the conceptual model efforts. There was a question whether the conceptual modeling can be done in ER Studio. As far as my knowledge goes, it's true conceptual modeling only focuses on the entities and not on the attributes. So there are two answers to that question. So as far as we could see, you can't do real conceptual modeling within ER Studio. So you can do the logical modeling, but obviously you can model solely entities without attributes. So yes, it can be done, but it's not a separate model within ER Studio. I think that's different from Power Designer, where you actually have three kinds of models within Power Designer, where you can really separate between conceptual, logical, and physical models. So, well, it can be done with a kind of, loop, so to speak. But to be honest, I wouldn't recommend it, because if you would do it in that way, then you have to make already a decision what will become an entity, or you need to decide whether or not something will become an entity or an attribute, which is basically well, we experience it sometimes hard to decide upon if you don't have an understanding on the conceptual level like we have within FCOEM. So that is why we really enjoy a focus on the conceptual modeling in CaseTalk instead of conceptual modeling within ER Studio. So a little bit elaborate, but this way of working really allows us to put the focus on the conceptual modeling once the logical model is generated initially 100%. So all the entities, attributes, relationships, keys, domains, and some constraints are 100% generated from the conceptual model. What we add to that are some data type definitions, like Roy just said. We do some naming enhancements using the override file. And if you really want to add particular check constraints, well, that is something you need to define within the logical model. It can be done within the CaseTalk model. And then again, the physical model is fully generated from the logical model. And a lot of technical concerns, whether or not you want to implement primary keys or indexes or additional metadata columns like a change hash or an insert date, are generated and added to the physical model. So that is not something the data modeler at either the conceptual or logical level needs to be concerned about. With that is with regard to the benefits and some of the merits of the different kinds of models. But as I said, we also ran into some practical challenges, and we'll walk you through those challenges. So obviously, as I said before, that it's, well, imperative, I should say, that this modeling pipeline runs as smoothly as possible. And well, one of the things we experienced along the way is that the quality of the BAS-script, the Visual Basic script, which is generated from CaseTalk, obviously determines whether or not that model deploys well within ER Studio. And to give you some ideas, is that this is a rather random sample from the VBA script, which is generated from CaseTalk. But some of the things we experience is that sometimes there are rows which contain double quotes that results in errors when you run the CaseTalk script directly within ER Studio. So then you have to resolve, you have to remove those double quotes in order to run that script successfully. And obviously that is something we, as users from these tools, expect should be solved. So some other experiences that all the keys, primary, foreign, and alternate keys in the script are numbered, which seems like a nice convention, but if the structure changes in the conceptual model, all the numbering restarts. So that leads to a situation where if you have a particular fact type which hasn't changed, and that fact type results into a foreign key relationship which functionally hasn't changed as well, it still can be once you rerun the generation from CaseTalk, result in a different number, which subsequently generates basically a difference between the previous logical model and the logical model you've just generated, although there aren't any functional changes. So that is something we also needed to resolve. And so on some other occasions, CaseTalk objects like, for example, super types and many-to-many fact types didn't transform correctly to the appropriate logical construct. So a smooth transition between the tools obviously is required to achieve maximum automation. Fortunately, the development team of CaseTalk reacts quickly to our support call. So on some occasions, particular errors or bugs were fixed within one day, and we could redeploy a new version of CaseTalk or a patch, and these kinds of drawbacks were solved as well. So that is a first challenge we run into. Roy will elaborate on some of the challenges we had with automation within ER Studio.
Yes, a lot of things we had to figure out ourselves because the object model is poorly documented. I think that the most convenient or most handy visualization was the object model you see on the left there. It's also in the slides afterwards. Yeah, one of the things that I've learned with ER Studio is that you learn best using the sample macros. There are a lot of sample macros prepackaged in the software. Use them. It will give you a lot of insight in the inner workings of the object model. Visual Basic for applications is not exactly the language that I hoped for when automating, but it still works nicely. I didn't find out how to run the macros outside of ER Studio, for instance, running them inside Visual Studio as a development environment. Would be awesome if it was a possibility. Yeah, there were some little bugs in ER Studio when you changed, for instance, the entity names or domain names. Yeah, the names disappeared after all. They were named entity 1, entity 2, and so forth. Resaving or re-editing them was the trick to do to fix this problem. DDL output is limited. For instance, we would like to have a create external table instead of create table. Those options were not available at the time in version 19.1. Yeah, and a lot of functions and methods and properties are not really documented. I didn't find them at all, the documentation surrounding certain object model functions. So yeah, that was kind of a drawback. I found out that if you created a watch, and if you entered the debugging interface, you were able to conjure up all the functions and methods that are runtime available. But it still didn't give me any insight in how those methods and properties worked. So it was a lot of trial and error. And also the process of adding custom metadata to the different objects inside the object model of the logical model was quite intuitive. But once again, once you know how it works, it's really not that hard. And that's also the main takeaway I gave. I think setting up the pipeline was a lot of hard work. The scripting, setting up, testing, debugging. But once you have it in place, you can add features and tests and stuff like that in relatively few actions. Yeah.
All right. I'll look at the time. So, Roy, I think we should do a quick wrap up. So just so we can answer some questions at the end. So some of the other practical challenges, version control, for instance, we do version control within Git, not something very fancy. Both tools come with an enterprise edition where you can store all the model artifacts within a database, within a repository, but mainly because of licensing concerns, we chose the versions where both tools just store their model artifacts in different files, and to allow for proper versioning, we decided to use Git. And you've seen some screenshots. We used Atlassian Bitbucket to do the versioning. As I said, that's rather straightforward, I should say. One comment is that if you look, these are the artifacts which are used within ER Studio. If you look at this particular line, the DM1 file, this is the particular model file which contains all the logical and physical models. But as you can see, we also create some additional files along the way. So these are some configuration settings which we use in comparing logical models and physical models. The DDL which is generated, but also, as you can see here, the overrides file which we create and update, they are all versioned within the same repository. So another practical challenge was, how do we do the handover to data engineering? Because if at first we just generated the DDL and said, well, success. That was something that didn't work very nicely, so we adapted that way of working a little bit. So what we now do is that the data modeler runs the DDL, which is created in a separate, what we call sandbox database, just to test whether or not the DDL deploys completely, which was necessary because sometimes we ran into some deployment errors, for example, indexes that contain the data types that were too large. So this allows the data modeler to fix all those kinds of issues. So what we then do is with the data engineer, we do a compare between the database we just deployed, or the tables we just deployed, with the development environment, which contains the real latest version or development version of the database, the model we want to change. The engineer uses, in our client situation, Visual Studio to do a compare between those two versions, so to speak, and both the data modeler and the engineer decide upon which model changes need to be merged into the actual physical development environment, which is basically this step, which leads to a new version of the database in the development environment. I'll skip this one, but obviously one of the challenges is how do you do that when you already have a model or a database in place? How can you add a modeling way of working to a situation where there's already an installed base, which is, well, this is something we thought about as well. And basically it comes down to reverse engineering the model which already resides in a particular implementation. Within ER Studio, we then decide which entities or which concepts need to be remodeled. We generate a new model for those particular changes. We do compare, and then we compare and merge, and then we merge those changes into the physical model, and then apply that to the database. Last one, how do we handle and propagate model changes in the pipeline? And obviously we need to do some change management, some version management on the override file as well, which is elaborated in this slide, which can, well, we depicted here on the right hand side, which you can read. So I would like to close with some lessons learned, and then we can address answer some questions. So our experience is that it is possible to model in an agile way while managing all relevant concerns, and I hope the modeling pipeline we have shown and the way we've implemented it has given you that idea as well. And as far as as far as our experience goes, is that the tactic that we have deployed obviously can be used in other data modeling tools as well. So we have made a deliberate choice for ER Studio, but some of the concerns we automated and managed within ER Studio can be done as well, for example, in Power Designer or Enterprise Architect. And one of the bigger conclusions of our experience is that we think there is a huge upside potential with regard to technology support and enhancing the practice of data modeling. So we have done a lot of automation and figuring out ourselves, and maybe our biggest lesson learned is that if vendors open up to support this way of working in a much more, the threshold to start data modeling and actually use data models in data engineering and system development can be lowered very much. Roy.
Yes, we found out that there are four takeaways for the vendors. The first one is that we want the vendors, or we would like to have the vendors open up their systems or their software to provide integration with other modeling tools and platforms and test more thoroughly. Please open up the internal object model to be used with external scripting languages like Python or anything else. It would separate the concerns even more, introduce more automation options, for instance, automated upload to Git, for instance. That was not an option right now, but you can even more. You can automate even more. The second one is that we would like to have the technical platform enhanced with the current development and engineering practices. So it integrates more with the way of working in modern organizations. The third one is that the product that we use from the vendors is never being used in an isolated way. It's never one-way street propagation of software or products. It's always integrated with other products and tools. So the vendors should look into this more. I know it's not their core business, but it's the way our organizations work. And the fourth takeaway or message that we would like to give to the vendors is to change the licensing model, to lower the threshold on new users, and to enable maximum platform support. Yeah.
So that brings us to the end of our presentation. Let's see, it has taken us exactly 50 minutes. So thank you very much for your attention, and we'll be here to answer some questions.
Yeah, thank you both. Yeah, we have a question from Marco. How does the client perceive this approach?
How does the client perceive this approach? Well, they are very enthusiastic. So in the sense that they see that they can put their modeling effort to the, as I told in one of the previous slides, into the conceptual modeling phase. So a lot of effort goes at the moment in the entire development and engineering into all kinds of technical concerns. And that is something you don't want to, well, in the end, you don't want to spend your time a lot with. So this modeling pipeline allows them to shift their attention to the real functional and business questions. So they're quite enthusiastic, and they've signed up for, I think the team is now about 5 or 6 what we call data management specialists or modelers. They signed up for the training to sharpen their skills, modeling skills, and to start using the modeling pipeline. Yeah.
We've just add one more. We've brought back the pipeline itself, brought back the time to market for a change to minutes instead of hours. So it also decreases the number of errors in producing the output. So we've done a lot of quality assurance in the process of delivering, SQL DDL, for instance. So everyone's happy. The data engineers see their concerns managed in a structural way in the model, and the data management specialists need not to worry about all the technical concerns in deploying a DDL.
Have you had any requests from clients to go from CaseTalk to a completely different kind of modeling tool, like a graph-based? Has graph-based played into any of the requirements yet?
No, not particular graph, but we had a recent discussion of with regard to data vault. So CaseTalk is also able to generate a conceptual, transform a conceptual model to a data vault model. And well, obviously some of the tactics we deployed here can also be used to further enhance and elaborate such a different kind of model. Yeah, it can be done in ER Studio or other kinds of tools or other kinds of platforms. Yeah.
And just one more quick question. So the slide showed more of a sequential kind of one CaseTalk model to one ER Studio model. Have you had requests to do a kind of a many-to-many there, where you might have gone from one CaseTalk model to several ER Studio models, or maybe from one ER Studio model to several CaseTalk models?
Yeah, well, it's a very good question. The answer is yes, we've looked into that, and we've made a decision not to do that. And that touches upon, I now realize we haven't really had a slide about that, but about the data architecture, because we have different kinds of areas, and within the same area we can have what we call different kinds of namespaces. So a namespace basically represents, so to speak, a business domain. So we have, each business domain has its own data model, but we need to make a decision. Is okay, well, one data model, what does that mean in terms of an ER Studio or a CaseTalk artifact? So we've made decisions that one business model is one CaseTalk project, is one ER Studio DM1 file, so to speak. So I can talk about that much more, but we've made some very strict decisions, so to speak, how we want to maintain. When do we create a new CaseTalk model? When do we create a new ER Studio model? And when do we don't do that? And how do we keep aligning those models with each other. So we have those tactics in place, but I realized we haven't shown that in our presentation. Yeah.
Okay, thank you. All right, well, thank you both very much. Okay.
Thank you.
You're welcome. Thank you.